Hey everyone, this video is about Qwen 3.827b, the model that went to #1 on Hacker News and picked up 2 million downloads in its first month. It has also split the people who actually used it, because one well-known reviewer says it wildly overthinks everything and another says that is exactly why it works. This video covers 5 things. The first is what the model actually is, the size, the architecture, the context window, the license, and what it can take as input. The second is the benchmark numbers. Alibaba published a full table on the model card, and it includes a direct comparison against Claude Opus. I'm going to read you those numbers, and then I'm going to read you the footnote underneath them, because the footnote changes what the numbers mean and almost nobody quotes it. The third is what independent people measure, which is a different thing to what the model card says. 2 organizations score this model on the same test they score everything else on, and that gives you the comparison against the current Claude Opus that the model card cannot. There are 2 findings in there I have not seen anybody talk about. One is that this model's score moves by 9 points depending on a single setting most people never touch. The other is a case where the same model on the same benchmark scored nearly 3 points differently just because it was run through a different agent framework. That second one matters far beyond this model. The fourth is money and hardware. What it costs is per million tokens if you rent it, what it costs if you run it yourself, and what card you need for that. And the fifth is my own testing. I put this model on a rented GPU, pointed a real coding agent at it, and ran some tests. So there are 5 facts about this model. The first one is the size. It is 27 billion parameters, and it is a dense model. The second one is the context window. It is 262,144 tokens natively, which people round off to 262k. Alibaba also says it can be extended to 1 million tokens. The third one is that it is natively multimodal. It takes text, it takes images, and it takes video. It is not a text model with a vision adapter bolted on afterwards. That matters for anyone doing document work or screenshot work, and it is why you see it scoring on benchmarks like OmniDoc Bench and Real World QA, which are picture benchmarks, not text benchmarks. The fourth one is the license. It is Apache 2.0. That is about as permissive as open weights get. You can use it commercially, you can modify it, you can ship it inside a product, and you do not owe anybody a revenue share. Not every open model does this. Some of them ship under custom licenses with usage limits written into them, so the license is worth checking every single time and not assuming. And the fifth one is the release. The open weights went up on Hugging Face in August 2026, and there are 2 checkpoint formats published side by side. There is the standard full precision one, published as safe tensors in BF16, and there is an FP8 one. The FP8 version is the one that went to #1 on Hacker News. The community has gone further again, and there are quantized versions that bring the whole thing down to about a 17 gigabyte file, which is what makes this runnable on a card you already own. Before I get into testing the model, let's go over the benchmark for the testings. I am going to read the main ones out, and then I am going to explain how they were measured, because the how is more important than the what. On the coding side, SWE Bench Pro is 61.7, Livecode Bench version 6 is 90.3, Terminal Bench 2.1 is 73.0, NL2 Repo is 42.3, Deep SWE is 42.2. On the agent side, which means using tools and operating a computer rather than just writing code, CoWorkbench is 70.7, JobBench is 33.4, and Agent's last exam is 42.9. On knowledge and reasoning, GPQA Diamond is 89.2, Humanities last exam without tools is 30.8, instruction following measured on IFBench is 79.5, and on the multimodal side, OmniDoc Bench 1.5 is 91.1, and Real World QA is 85.9. The vision gaps against Opus look far wider than the text gaps, and nobody talks about them. But 3 of those rows need explaining because they are not what they look like at first glance. Math Vision, Baby Vision, and Charhaf are each reported twice, in 2 columns labeled without CI and with CI. CI is the code interpreter. Without it, the model answers from reasoning alone. With it, the model can write and run code to work the answer out. So on Math Vision, Qwen scores 90.0 without the code interpreter and 94.6 with it. The Opus figure in that row is 65.5, and it is a without CI number, which means the 94.6 against 65.5 comparison you will see quoted everywhere is a with code score against a without code score. The like for like comparison is 90.0 against 65.5, which is still a 24-point win, so the point survives. It is just not a 29-point win. Same pattern on the other two. Baby Vision is 65.7 without and 85.6 with, against an Opus 12.6 without. Charles Shiv is 83.7 without and 90.2 with, against 66.0 without. Use the without CI numbers when you are comparing because those are the ones measured the same way on both sides. Two more caveats on those rows, both from the footnotes. Some incorrect ground truth answers in Math Vision and Charles Shiv were corrected by hand, and every score on those benchmarks was then computed against the corrected answers. And on Math Vision, Qwen 3.827b was evaluated with one fixed prompt, while for the other models they report the higher of two prompt variants. That last one is a small thing, but it cuts against Qwen not for them, which is worth saying. Now the comparison everybody actually wants, which is against Claude Opus. Alibaba put that comparison on their own model card. Here is what it says. On SWE Bench Pro, Qwen 3.827, B scores 61.7, and the Opus figure they cite is 53.4, so Qwen is ahead by 8.3 points. On LiveCode Bench version 6, Qwen is 90.3 and Opus is 88.8. Qwen is ahead by 1.5 points. On OS World Verified, which is the computer use benchmark, Qwen is 84.3 and Opus is 72.7. Qwen is ahead by 11.6 points, then it turns around. On Terminal Bench 2.1, Qwen is 73.0 and Opus is 78.2, so Opus is ahead by 5.2. On GPQA Diamond, Qwen is 89.2 and Opus is 91.3, so Opus is ahead by 2.1. And on Humanities Last Exam, Qwen is 30.8 and Opus is 40.0, so Opus is ahead by 9.2 points, which is the biggest gap in the other direction. So the shape of it is this. On the benchmarks that are specifically about writing code and operating software, the 27 billion open model is genuinely ahead. On the benchmarks that are about hard reasoning and general knowledge, the closed model is still clearly ahead. And the gap on the hardest reasoning benchmark is 9 points, which is not close. It also matters for cost, and the same table has that too. Cost per task for the 27B at extra high is 25 cents, at medium it is 19 cents, at low it is 17 cents, so you are paying about 40% more to go from medium to extra high, and you are getting 9 points of index for it. That is an easy trade and you should take it, which is the opposite of the conclusion most people reach when they see a slower setting. For comparison, Opus 5 at max effort is $2.34 per task, against the 27B's 25 cents. That is roughly 9 times the cost for 11 more points of index. So on an independent index, Qwen 3.827B is last of that group. It is 11 points behind Opus 5 and 8 points behind Kimi K3 and GLM 5.3. If your only question is which model is smartest, the answer is not this one and it is not close at the top end. Two ways to pay for this model and they are very different. The first way is to rent it through an API. On OpenRouter, Qwen 3.827B is 40 cents per million input tokens and $3 per million output tokens. Compare that to Claude Opus 5, which is $5 per million input and $25 per million output. So Qwen is about 12.5 times cheaper on input and about 8 times cheaper on output. That is not a rounding difference, that is a different category of spending. If you are running an agent that reads a lot of code, and agents read enormous amounts of code, the input price is the one that will dominate your bill, and that is the one with the 12.5 times gap. Now here is what I did for the testing. Because I don't own a good consumer GPU like 4090 or 5090 GPU, I created a runpod container which runs the Qwen 3.8 VLLM model, and then I connected to the runpod machine with my laptop. The rig is an RTX Pro 6000 workstation with 96 gigabytes rented on runpod. The model is the full precision checkpoint served with VLLM. So the first test is just building things, one HTML file, no libraries, nothing to install. I paste a prompt into Pi, it writes the file, and then I open the file and play it. That is the whole test. Let me start with Snake because it is the simplest one. This is the prompt, it is on screen now. 8 numbered requirements, and the last 3 are the ones I actually care about. Pause on the spacebar, the snake speeds up every 50 points, and the high score has to survive a reload, which means local storage. Those 3 are where a model that has memorized a snake tutorial starts dropping things. I pasted that in one shot, no follow-ups. It wrote the file itself in about 2 minutes. And here is the result. So that is the game running. You can see the score in the corner going up by 10 each time. Next one is Boyd's. Same deal, one prompt, one file. And here it is, 200 birds, and you can see them actually flocking rather than jittering in place or collapsing into a dot, which is the usual failure. The sliders in the corner are live, so I can turn separation down and watch them pile into each other, and turn it back up and watch them spread out. And if I move the mouse into them, they scatter because the mouse is the predator. Then cloth, Verlic cloth simulation, one prompt, here it is hanging. The thing to watch is that it is still. A lot of cloth simulations shiver forever, or they explode off the screen in about 2 seconds. This one settles and hangs. I can grab it and pull it, and it follows the mouse, and if I shift click, I tear a hole in it. This is the one I care about most because it is closest to what you actually use one of these for. So I took a small Python project, a shop. There is an inventory file, an orders file, and a pricing file, and there is a folder of tests. I broke it on purpose before the run. 7 failed, 12 passed. The job is to get all 19 green, and the rule is that it is not allowed to touch the tests. There are 7 broken tests, but there are only 4 actual bugs. One bug is breaking 3 tests at once. So the easy way to do this is to look at each red test, patch whatever it complains about, and go 7 for 7. That looks like success, and it is not. The right answer is to notice that 7 complaints are coming from 4 places. Here is the run. I gave it the prompt, and this is it working. It made 17 tool calls. It read the files, it ran the tests itself, it made its edits, and it ran the tests again. 3 minutes and 52 seconds, start to finish, one go, no help from me. And here is the end. 19 passed, all green, it found all 4. The front end test is 1 page self-contained with a hero section, 3 feature cards, a pricing table with 1 tier marked as recommended, a footer, a considered dark palette rather than just a black background, and it has to stack properly on a narrow screen, 6 out of 6. 1 turn, 1 write, and the output is 20,222 bytes across 760 lines, all self-contained with no external anything. Everything in this video is in a repository and the link is in the description. That includes every prompt and the runpod and vast.ai template I used to run the LLM model in full if you want to test it out yourself. Thanks for watching, and I'll see you in the next video.